this is a non-null value. This is not 0. So if this is not 0, then it will out true. And now the next rule in Python, whenever you are writing if-else statements, for loop, while loop, etc., we need these colons by the end of your that decision making or loop statement. So these colons will automatically add one indentation in your next sentence. This indentation is very much important in Python. So when you have a block associated to your condition, that will be written at a slightly distant position from the initial position, such as if we have at this position, then the next, for example, I want to execute just this one, got a true expression inside this, and then I want to just print the variable value. So these print statements at the moment are intended slightly ahead of the normal position. And these indentations make them a part of this condition that we are testing with the if statement. And for instance, if we use one print statement outside this, I'm just writing a random sequence over here. This print is currently outside your if condition, since it is on the same level as that of if. This thing we have to learn very carefully, because this will be applicable in all decision-making statements and loops, etc. So currently, if I run this code, and you will see, since 10 is a non-null value, so condition will automatically turn out to be true, and it will execute both internal parts of this condition as well as the external part of this condition. Because first it will go inside the if condition, and then the outside block will be executed. The second case, let us make this variable 1 is equal to 0. When I make this variable equal to 0, this if condition should automatically turn out to be false, and these blocks should not be executed. Rather, it should jump to the final statement instantly. So if I run this, you can see only goodbye get printed. Now I have one question. See, I'll make one small change in my program. I'll just shift this print on the same position. And you can see here, this variable 1 currently is 0. So just tell me, if I execute this program, what should I get in the output? You can update me quickly in the chat box. See the current position of the program print commands and as well as the variable that we have initially. What should be the output of this particular program if I run it now? Okay, so you say no output. I would require participation from most of the candidates who can reply, at least update whatever you are understanding out of this. This should be an interactive session. Okay, so what we have here is, since I have shifted it on the same level, so this is true that we will not get any output at the time because this is 0. And if I make it a non-null value such as 20, in that case, again, all 3 will be executed since they are part of your command. And if I take this back on the same level again and make this 0. So at this moment, again, only goodbye will be executed. The internal block will be false. So this is how indentation will play different roles in your Python program. So I'm sharing this initial code in Snipper right now, and you can all execute this. After running this we have designed with a simple if statement. Let us see if we have a combination of if-else statement. Because when you have only one condition to test, you can just print a block of statement based on that. But maybe you have an alternative thing also, for which you need to print a set of blocks or maybe some set of commands you have to execute. Then else statement will be utilized. Else will print the otherwise condition. If the condition turns out to be false, it will switch to the else part. And else condition, do not test any condition anytime. It will just take the alternative of your if condition. So if I write one variable like I is equal to 10 here, and then I'm creating a condition if I is greater than 20. This is my first if condition I'm updating. And then based on this, I'm just writing a few block of statements. First, I'm printing value of I, then maybe a simple set of commands. This is true. And then I'm coming to the else part. See this very carefully. The else associated to this if has to be on the same level. To this if, it should be on the same level. And then the else block will be again intended. So here also, for example, I'm printing first the value of I and then a statement, this is false, so that we can just recognize if it is swinging between both options. And then one final statement I'm having here, which is outside both blocks. So this is a outer block right now. This portion belongs to else statement. This portion belongs to your if statement. So if I execute this one, you can see the else part is working. This will work in every condition, whether if is executed or else is executed, because this is the outer portion from the if else command. Similarly, if I make this 130, it should execute this portion along with the final statement. See, we can have this. But now, one thing to observe, I'll need quick responses in the chat box again. So if we have shifted this print to this position, now tell me how many lines or which portion which we will have in the output when we have changed the position of final if statement, final else block. So only if I got one reply, looking for others. Consider the concept of indentation. Okay, so if I run this part, what we'll have in the output? Only this part, since now goodbye is the part of else statement. So you just have to take care of this indentation, and indentation of one level doesn't interfere with other, but they have to be on the same level when they are in one block. For example, if I take them further to one next level, they will not have any error because they are currently all on the same, because else block is separately executed. So they should be all on the same. But you cannot have a single block at different levels. You can see the error line started instantly because one block has to be on the same level. So these simple mistakes you have to avoid while writing your programs. I hope this is clear up to this point. If anyone wants to respond in the chat box. Okay, thank you. Students, be active in the chat box also, because then only I'll come to know if you are learning things or not. So next we have one more, that is ellipse statement. We'll just learn this one also. When we have multiple conditions to test, since here you can see we can test only one condition. But if you have multiple conditions to test, we can use a combination of ellipse statement in that case. So for instance, I'm using one sequence here, variable is equal to 250. And with this, I'm testing here multiple conditions. First is variable is equal to 300 is my first condition. Then I have to print here. For example, I'm writing here, expression is true. I'm writing one here just to ensure in which loop I'm entering at a moment. So that part I'm doing here. I have shared the previous code also in the snippet. So here, first part, and then probably we can also print the variable value. Then the second part now. elif statement to test second condition. And that we can do by using probably one alternative option here. And I'll be using another block of statement associated to this. So this I'll say 2 expression got true. And similarly, you can now test any number of statements in the same format. We can have any number of these elif statements together. I'll use just 2, 3 to create a visualization of this element that we are using here. For example, we say this is greater than 200 and this makes your third expression true. And then ultimately we have the final else statement, which prints the otherwise condition. So we can say here the fourth element, which says none of the conditions is true, or we can say all false, anything you can write here. So now we can see here, if I run this part, it says third expression is true. So this part, why? Because variable is currently 250, which is greater than 200. So only this will be executed, none of others. And when we have these if-else statements in sequence, it will just execute only one of these, the one that gets true, and all other will be skipped by the program. So when it is getting this one as true, all others will be automatically skipped by the program, and it will be focusing on this one only. This is how you can test multiple conditions. And in the similar manner, you can also work on the nested conditions. So I'll not be working on that here, but yes, you can do nested if conditions also. You can expand it further to multiple levels, and you can have them on the different combinations. So this completes your different types of decision-making options. And next to this, we can also have your Python loops. So in Python loops now, the first we'll be covering is a while loop. And in your while loop, we can test again, we can just update a condition, and as long as that condition is true, we can execute a block of code based on that. So for instance, I'm creating a count 0 here, and then I'm updating a while condition. And that while condition here has count less than equal to 7, for example. And the rule will be same. We need a colon by the end of the statement, same as your if else. And inside this, for example, I'm printing some random details like count is. So the current value of count gets printed automatically. And then we are updating the count every time with count plus 1. And here I'm updating done. A simple loop I have created. So initially the count value is 0, and we are going to run this loop repeatedly until your count value doesn't get above 6, because this is considering it less than equal to 7. So accordingly, the values will be updated, and we are incrementing count every time. So let us see what we get in the output. If I run this, you can see we start from 0 and goes up to 7. If you have just less than 7, then it will go up to 6. Depending upon what condition you have updated, accordingly it will be behaving here. And once it has executed the loop, then only it will go to the outer statement, which is here, print at the time. So I'm now making one simple change in this program. I'm shifting this print statement to the same level. Just give me a quick update in the chat box. What should be the change in the output right now? What changes we can expect in the output? Okay, good. So done will be printed after every count. This looks right. And if we implement it here, you can see done will be printed after every line, because now we have made it a part of your while statement. So this is how indentation will play a role in your loops as well as in your decision-making statements. So I'm sharing this code also in your snipper, and you can practice it side by side. It is even possible to create your while loops with the else statement. That also you can do. All kind of loops, for loop, while loop, you can do with the else statement. Let us do one example of that also. While with else also you can do. So we can switch here and then we can write, and maybe after this you want to update the else command, and here we can write the print statement. The count is not less than whatever value you have entered here. So for example, if it is 7, so depending upon how you want to make it appear, you can update this. So I'm just writing the count value also here. So if I execute this one, it says it will execute this entire portion one by one, and then ultimately it says the count is not less than 7 anymore, because this has turned out to be 7 now. If we have equal to, then the output will be accordingly updated. And this is important to note that in case of your if-else statement, the else block was executed only if the if part turned out to be false. But in case of your while loops or for loops, the else part will be executed when the loop is over. So else will be executed always, but only after completion of the loop. So it will not be skipped in the program. Rather, after the loop, this part can be executed. So I'm sharing this tiny code also in the snipper, and you can execute it. This turns out to be your while loop. And in the similar manner, we'll take up one example for loop in Python. You can have different conditions to use this for loop also. I'm using just one simple example here. Possibly, we are trying to iterate through one sequence here for I in Python. So I'll be iterating through this string over here. Just a simple example I'm taking, and then we can print the current letter out of this. And that current letter will be I, because we are iterating through these elements and we are every time storing values in this I. So let us see. Current letters will be printed one by one. P, Y, T, H, O, N, everything one by one will be printed with this sequence. You can apply for loop also in variety of conditions. Just some technique we have learned here, that how you can run the program for this. Just give me a quick update in the chat box if we are clear with the decision-making statements and loops. Then we will switch to the function definitions. Okay, thank you very much for the updates. And now we are switching to another topic, which is your function definitions in Python. And as I have discussed yesterday also, there are several inbuilt functions as well as user-defined functions. Inbuilt functions are the ones that are already in your Python platform, and we can call them anytime and we can use them. And many of such functions we have already used. One best example can be your print function. We have used that several times, which is also a inbuilt function. And similarly, when we talk about a user-defined function, that is when we are designing a function and we are using it for a specific purpose. So that also is possible. So first, let us use one simple inbuilt function. Just to have an idea about this, we are just brushing up the concept, and then we will learn designing new functions. So inbuilt function, for instance, we have for n in range 1 to 10. Just a simple program I'm creating. We have to print the value of n, for example, here. So what we have here, this range is an inbuilt function, and this print is also an inbuilt function. There are thousands or maybe lakhs of inbuilt functions available in Python that you can call depending upon your requirement. And what this range function does basically, it will count from the starting position to 1 less than the ending position. Same as we have seen with the slicing operation. So it will count from 1 to 9, 1 less than the ending position. Many such functions you will find in Python, and we are just printing the value of n every time. We can also modify some of these functions further. For example, I just add one end statement, and instead of having these values in this format, I'm using them with the space separation over here. And we can see this one. I can add space here, and we can see them separated with space. I can add comma here, and we can see them separated with comma. These are different design elements you can add as per your requirement. So different types of operations we can do with these inbuilt functions. I have just shared this one also in the snippet, and you can try this inbuilt function. And after learning this, just a basic inbuilt function utilization, we are going to define a new function with your Python platform. So I'm writing a task here, defining a function first without parameters. We'll just learn few different samples. There are unlimited things that you may need to learn in every category, but considering the time limitations, I'll be focusing on the most essential ones here. So I'll just tell you how we can create functions with parameters as well as without parameters. That is the most important part. So first, without parameters we are creating. For example, I'm creating a simple function here, message function. And you will see here important things. When we are defining a new function, this def keyword will be used. We have seen list of keywords yesterday. And from there only we are using this def. You can see in color because this is an inherent keyword in Python. After writing def, define statement, then we write name of the function. So currently this name is message. You can have any name for your function as per your choice. Just we do not prefer to use some reserved keyword for the function names. Otherwise, you can use any name for your function. After this, I'm using empty braces, empty round brackets, which is required when we have function without parameters. Otherwise, we will enter some parameters inside these brackets. So currently, let us see. We will just print a random statement here. Welcome to the Python course. So this is a simple statement. Why we need functions? When you have to execute certain statement or certain set of blocks multiple times in your bigger program, but you do not want to write those blocks time and again. So you can create a function and you can call it anytime. So currently I'm creating this function with just one line. It may even have hundreds of lines within, and we need not to write those lines time and again when we need it. Rather, we can just call it with function name and we can access all those 100 lines of codes easily. So first set we have is defining a function. And then in the second set, what we have to do is calling a function. There will be two parts of function always. One is function definition and other is function call. So in order to call this function, we just need to use the function name. And because this is a function without parameters, so empty brackets will be utilized and it will call all the blocks that we have inside this automatically. So you can see with this function call, we could print the statement directly. And every block or every line of code which is associated to your function will be again intended. So if I have to enter maybe some more details here, like maybe we have 2 + 3, maybe just a random thing I'm adding here. So it will be updated accordingly in the output. You can have any number of blocks in the similar manner. So this creates your simple function definition. I'm sharing this code also in the snippet and you can try this. But now the next point is that you may not always need function without parameters. Sometimes we need to restrict it to use a specific number of parameters. So in that case, you need to learn defining function with parameters. We call them arguments, we call them parameters, we sometimes also call them attributes of your function. So there are different names. Some values that we can pass into the function for certain executions required inside. So what we can do here is, I'm designing one basic function again. Define function. Function name is course. For example, this is one basic function I'm creating. And inside this, I'm using two parameters. One is name and second parameter is course underscore name. Two parameters. So the parameter names should be, or the parameters should be separated by comma. And you cannot have space between parameter names. It should be connected with underscore, etc. There should not be space between parameter that you are passing through. So two parameters in this function, and inside this, I'm just creating one random set of statement. For example, hello, using the name value from here. And then next we can have welcome to the class. This is the first set of statement. And then next we can have possibly your course name is, and after this we can print the course name. So this is a simple function with parameter I have created. Consider this in a scenario, maybe you are designing a website or a mobile application with this Python language, and there you want to allow students to enroll for certain course. And whenever they enroll, you want to send them a welcome message. So they will just fill up their registration form, and from there you can get the name and the course that they have selected from their form. And then you can put those values inside your function automatically, and they will be calling in the similar pattern. And we can have this function called here, for example, course. So maybe the student entered name as Zara, and maybe the course name they entered as Python programming while registering to your course. So these things will be automatically taken up by these values here. So if I run this part, we will see this gets automatically updated in the sequence over here. So in the similar manner, you can have any number of parameters in your course, and you have to pass their values right here in sequence. So when we have this type of, these are positional arguments, the position matters. So they will be taken up in the same position. So first will be passed as a value to this name, and second will be the parameter value to this course name. And accordingly, they will be updated wherever you are using them further. So I'm sharing this one also in the snippet, and you can use this code. Just give me a quick update if it is clear up to this level. Okay, thank you so much. Good to see the responses. So let us design one simple function over here. Let us consider a practical application of the function also. Create a function to check if number is even or odd. A simple function I'm creating here. And inside this, first of all, I'm creating function name even odd, for example. And inside this, I'm passing one value only. You can have different types of functions. I'm just creating one basic one here. In order to test if a value is even or odd, we can use modulus operation, which is commonly preferred in mathematics also. So modulus in Python, we use with percentage sign. So modulus of this is equal to 0. Just a mathematical condition I have updated here. A combination of function if conditions I'm using. Then print this as an even number. Else, we can print this as an odd number. So when the modulus is not equal to 0, it will automatically be considered as an odd number. So this becomes your function definition for even odd number. And we can call this anytime. And this allows you to pass one value. Currently, we have only one parameter in your function, so we can just check this. It says 3 is an odd number. And maybe if we check 4, so it says 4 is an even number. A simple function to test your even odd numbers. So I have shared the code for this one also in the chat. One more condition we can use here is, I have shown you this without parameters. I have shown you this with 2 parameters also. There are several other concepts also, but I'm just concluding it with one more concept here. That will be function with multiple parameters. So when we have a function with multiple parameters, or we can say it more precisely, variable length parameters, how you can create them. For instance, I'm writing here a function for addition of any number of value. See, addition, but not with 2 numbers only. We have done it yesterday with 2 numbers, but not with 2 numbers. I wanted with any number of entries, so that a person can use this as a full-fledged addition counter. So what we can do here is we can slightly improve our program. First, I'm declaring a total over here, total equal to 0, and then for number in numbers. So we are just iterating through these numbers depending upon how many numbers are there. And then I'm just updating my total value every time. Initially, I have taken total equal to 0 so that the first number can be entered into this mathematical sequence. That is why total is 0 initially. But later on, it will be updated based on the equation. So 0 plus 1, it will be saved as 1, and then the further values will be added up automatically. And ultimately, we can print your sum. So that will be here as total right now. So that will be updated as per the for loop condition. So this is your simple function condition. When we have variable length argument, we just need to add the star mark before your variable element that you are adding here. And for function call, what we can write now, this can use any number of parameters. Even you can have empty. If you are not passing anything, then also it will work. Otherwise, you will have error. So for instance, I'm writing here any number of values. It will work with them. So if I run this one, you can see it works with all of them perfectly well. Now we can have any number of parameters. If you use the same thing in the previous case, you will have an error. For instance, if I add here one more value, like 4 and 5. So it says that your function takes only 1 argument, but you gave 2 arguments. So that error you will get in normal functions. But when you need it with variable elements, we can just use this star mark and it will work fine. So I'm sharing this one also in your snippet. You can use it from there. So these are your operations on basic Python till now we have worked upon. And although there are many other things also you will see in the Python program, but since we have to cover many other things in this course further, so I have just concluded it with all the essential things that you need for as a beginner in Python programming. And just give me a quick update that you have got the Python concepts by now, and we can move ahead with the new topic further for the course. If anyone is in doubt anywhere, please update me quickly. I'll be switching to the new topic after this if you reply that if you are fine with up to this point. Okay, so I can see only one response in the chat box. So if no one is responding, I'll just consider that this is going fine with everyone because that is only I can understand. So fine. Now we are going to start ahead with your machine learning concepts, and as well as we'll be working on some data visualization concept. So I'll not take it much into the theoretical portion since we have to implement more important things further. But yes, we'll do a little bit of introduction on your this machine learning concepts. And for this, I'll be talking about a few different details, and that I'll be sharing with the whiteboard from here. Just a minute.
Ma'am, Tushar is saying that last topic function need to be explained.
Okay, so if you want more details on functions, okay, just let me go to this again. See, when we have these functions, why we need, first important thing, why we need a function? Functions we require when you have a set of block to be executed maybe multiple times in a bigger program. Currently, we are not designing a bigger program, so maybe this will not look like more relevant. But when you have a set of code that you need time and again in a bigger program, we can save that inside a function, and then we can call it anytime by using this function call. So first, we designed a very basic function over here just to print this statement. I have used only one statement here. You can have like thousands of other statements within this function, and they will be all executed whenever this function is called. So currently we can have this one here. First, we need function definition. DEF keyword will be always used when you are creating a new function. After this, we need your name of the function. So currently this is message. You can have any name for your function. After this, we have these empty brackets since I'm creating a function without parameters. If you need a function with parameters, that also we have seen here. We can pass the parameters within this function sequence, and then we can pass values to these parameters. In the first case, since there is no parameter for the function, so we need not to pass any value here. Rather, a set of commands that are associated with the function will be automatically executed. So this is your first basic type of function. Then we have this one with parameters. So whatever you are passing to these function parameters, that will be updated in your inbuilt sequence automatically. So when we have it with name parameter, I'm passing this name. Course name parameter, I'm passing this Python programming. So it will be automatically taken up at required position. This is with the help of your parameter values. Whatever parameter values we are passing, they will be updated at required positions. You can see here, at this position, we had name. So it is updated with Zara. At this position, we were having course name. So it is automatically updated with the second value passed into the function. So you can have any number of parameters in the same manner. For example, we add age also. So we can write here age, and then the value will be passed. So for age, maybe I'm passing here another value, and it will be updated. Since we have 3 parameters, we have to pass 3 parameters, and accordingly, they will be used inside function anytime. You can even design functions to solve some mathematical equations. You can design functions to control your applications on mobile or website. Everywhere you can use these functions. In the same sequence, we have also seen functions with variable length arguments, where you don't want to control, or you don't want to limit that this will process only 2 parameters or 3 parameters. Sometimes these type of functions are also required. So this you can do with the star mark over here. It will help you to add any number of parameters into the function. So you can see here, we can have empty one, we can have 2 values, we can have 4, and any number of values we can pass further. So this is just a simplified introduction to your functions. You can create them and you can call them anytime. Once you have created this function definition on a single sheet here, it will be active throughout your program. You can call it anytime throughout your program. Just tell me if it is clear now. I cannot see messages in the chat box if anyone is updating anything.
Yes, ma'am, he is replying. It is clear, ma'am.
Okay, thank you so much. So
everyone, please, in the two, you have to select everyone. Then everyone can see your messages.
okay, so next to this, now we are about to talk about your machine learning basics, and for this I'll be using the whiteboard here. So sir, is my whiteboard visible right now?
No, ma'am, I think you have to stop share, then you have to start the whiteboard.
Okay, fine. So I'm just opening it up again. So I hope this is visible now.
Yes, ma'am.
Okay, thank you so much. So I'll be just discussing a few concepts here about machine learning, and then we'll be proceeding ahead with data visualization on your Python platform again. So first of all, since there are so many concepts involved, I'll be just focusing on few essentials. First, when we talk about data science or when we talk about machine learning, the first thing that you need is a data. Nothing is possible without data. The first thing you always need is data. So that will be your first requirement. And now within this data, we have different options. When you access a kind of data in your system, it can be, we can say like we can quantify into different types. One option you can have is, we call it qualitative data. And the second option you will see is with quantitative data. Okay, so two options we have, qualitative and quantitative options over here. And for each one of them, how we categorize it further, if we just consider the options for different types of data, because this is the most important thing. You first need to understand what are the different categories of your data. So I'm just updating one sequence over here. If we can see types of data, we have first category as qualitative and other we have is quantitative. Now, in case of qualitative data further, you have options for nominal data as well as you have options for ordinal data. These are the two categories in case of your qualitative data. And similarly, in case of quantitative data, we can have discrete data and we can have continuous data. Whenever we have to apply some data visualization operations or some different data science operations, we first need to understand what type of data we have in hand. So in all these categories, if we try to move one by one, these entries that we call qualitative data, they can be in the form of some string values, they can be in the form of some specific set of classes, they can be in an ordered sequence also. So qualitative data, for one example, we can take just as a gender information you have, male, female, you have two categories out of that. That becomes your qualitative data. However, in case of quantitative data, we have some continuous information. That continuous information can be like we have temperature values, we have humidity values, they are continuous informations. Now further, with the nominal and ordinal data. In the first case, in case of nominal data, what you have is some values that cannot be compared with each other, considering the one is greater than or other is less than. We cannot apply order on these nominal entries. For example, if we consider gender information, like we cannot say male is greater than female. That is not possible. Similarly, if we consider color information, we cannot say black is greater than brown. So that becomes your nominal data. Similarly, some qualitative information you will get in the form of ordinal data as well, where we can simply create an order in the sequence, such as we have maybe size of t-shirts. So we can say that Small is less than medium and medium is less than large. That is, size of t-shirts can be ordered somehow. Similarly, we can say like educational levels. We can state it with higher, secondary or primary, and we can easily say that one is greater than other, and we can compare them in sequence out there. So while working on these sequences, you can even apply different types of operations on your data. So depending upon what type of data we have in hand, we choose different operations. Like for ordinal data, the type of plot or the type of graphs you choose in data visualization will be different. However, for the continuous data, the technique may be different. Similarly, when we talk about your continuous data that belongs to your this quantitative structure, discrete and continuous, these entries generally have, we can say like some long-term sequences, some continuous values or some values that cannot be categorized into a limited number of classes. Rather, you have a long-term sequence. You can have some statistical manipulations on these. When we have the color information, we cannot apply any statistical procedure on them. But on your quantitative data or the numerical data, we can apply different statistical procedures. We can calculate their mean value, we can calculate their median values, we can have standard deviation, different operations we can apply on quantitative data. And while working on this, you will again find two things, continuous and discrete. In case of these discrete data elements, we generally have whole numbers or integers only. However, in case of continuous data, we can have floating point numbers also. So when we are talking about like days in a week or months in a year, they may come under the category of discrete data. However, when we talk specifically about temperature or humidity data, that will become your continuous data. So depending upon what type of data we have in hand, we can choose different visualization techniques for this, and we can have different stats gathered out of these values. So considering these concepts, when you have obtained your data set, because machine learning also need a data set first of all. So when you have obtained any of these type of data, so generally we have mixture of data. It is not possible that you will have in your data only quantitative values or only qualitative values. This is very rare. Most of the time you will have mixture of data. You will have quantitative also, you have qualitative also, and every time we need to apply different operations on that. So when you have the data initially, then further you clean it, you pre-process it, you apply different analysis approaches on this, you just understand the pattern of your data, and then ultimately we develop your machine learning models. But before developing any machine learning models, we need to understand what it is basically. So this machine learning is basically considered as a subdomain of your artificial intelligence. We have multiple things here. The original domain or the wider domain that we have is, we consider it as artificial intelligence. And what is artificial intelligence? It is basically, we can say like, we are trying to mimic human brain into some machines. That is your artificial intelligence. So whatever abilities we have with human brain, or whatever decision-making possibilities we have with human brain, we just try to utilize them to create a machine learning model, or we can say like to train a model that can make decisions on a specific application. So taking it on the brief concept, what we may have in this, in case of artificial intelligence, whatever trainings you give to your model, accordingly, it will give some predictions to you. And the further categories of this, we have machine learning, we have deep learning. These are the normal categories we find. In case of machine learning, we apply some statistical approaches. Statistical approaches that are inspired with some mathematical modeling, with some statistical mathematics behind, or we will have a complete model defined with the help of some statistical variables behind that will help you to predict something. However, in case of deep learning, we have multiple layers of a neural network, and that neural network considers your basic artificial ANN structure, artificial neural network structure, but with extended number of layers. So in general, when we apply a machine learning algorithm, since this is a mathematical model, it requires a clean data set. So when you apply machine learning, you need clean data set first of all, and this cleaning procedure requires you to implement data science approaches or data pre-processing approaches. You will have to deal with outliers, you have to deal with noise in your data, you have to deal with missing values in your data. You may even have to transform some features, like you may need to convert one feature to other. Some object values you have to convert into some number-based values. Several operations are there, unlimited things you can do on your raw data. And that raw data, when it is obtained in a cleaner version after applying all data pre-processing techniques, you will get it ready for the machine learning model building. So it means we have a general statement while building this machine learning model that we need 80% of the time for data pre-processing, for data cleaning, for modifying it, for manipulating it to make it ready for your machine learning model building. We need 80% of the time. And only 20% time is required for machine learning model building. However, when we talk about deep learning, in case of deep learning, we do not apply any data science approach. Rather, we have multiple layers within your neural network, and each one of them can process your data automatically right from the scratch. So layer after layer, the model will learn the pattern out of the raw data itself without requiring any pre-processing procedures. So we can say like the data pre-processing requirement get vanished when we have deep learning. That is why most of the researchers these days are shifting towards deep learning, because it helps them to skip the data science procedures. And they can just apply a raw data into the model directly, and it will learn everything from scratch. But when we have a simple mathematical modeling requirement in your project or in your research, then of course you have to go ahead with first your data science, and then you have to proceed with your model building process. While working on this, for deep learning, we will have different concepts with CNN also in the coming sessions. But when we talk about the machine learning procedures, in this machine learning procedure, we can first, or we can say like basic neural network, you can categorize into 3 different parts. First we have is supervised learning. Second part we have is unsupervised learning. And third we have is reinforcement learning. These are the 3 different categories. And each one of them have their own importance in terms of how we execute our projects on this. So first case, that is the most frequently used one. We have the supervised learning case, first case, where we say that your model has a supervisor to monitor the outcomes. And from where that supervisor comes basically. In case of your supervised learning, we say that we know the target from your data set. I have also shared some data set in your maybe sir has provided it through some common platform where you can access it on Drive. So from there, you can see that we have some data sets that contain some features as well as targets, and they are available in some structured format. Those structured format we call like, you know, the type of features. You are also aware about different types of target variables available out there, as well as you may also know about different options. For example, I just picked up one image for your easy understanding here. And we have some input raw data that is available initially from your any domain that you can consider, maybe from online sources or from IoT sensor networks. Then you have one algorithm, one machine learning algorithm that you are trying to train with this supervised learning. We can say like simple artificial neural network algorithm we have over here. It will contain a training data set along with the desired output. Consider the case that we have maybe a data set from certain medical domain. And it is a patient information as well as some healthy members information. So from that information that we have obtained from the doctors, we'll come to know that if a patient has these and these conditions in their body, they will be affected from certain disease. And if these things are not present, they may be healthy patients. So both categories will be there. So from there itself, you will come to know that these features produce this kind of output. So the desired target or desired output, you already know. And this output basically helps you to supervise your model performance because you know the output. And every time you will compare your model performance with that output, that whether it is able to predict it right or not. So that becomes your supervised learning, because we are able to compare it with an output all the time. And this will further help you to get categorizations between whether the person is healthy or unhealthy, or if you have any other application. So for all of them, it will work directly. So in general, for the supervised learning, we have two categories to work upon. One is your classification and other is your regression analysis. Two types of common analysis we will have in supervised learning, with regression and classification, and how we generally differentiate between both of them. So initially, if we talk about the classification task, it is something like when your target variable has only a limited set of categories. We can have a binary classification problem, or we can even have a multi-class problem, such as we can see one example here in image. Maybe we are training a model to identify if the image belongs to a boy or a girl. And you want to deploy this model maybe in a conference hall where people gather for different events, and that can quickly give you an idea whether there are or how many number of males are there or how many number of females are there. So this model may help you in that way. So what this will do basically, it will just give you output in two categories. So this becomes a kind of classification, either one class or either zero class. So we call it a binary classification problem. We can even have a multi-class problem. Currently, we are having only two classes to work upon. One is male and one is female, girl or boy, two classes only. We can even have multi-class problem, such as we can have, maybe you are getting some survey information from where we are getting ratings as excellent, good, bad, poor, these 4 ratings. So this becomes a multi-class problem when the target can be categorized into more than 2 classes. That becomes your multi-class problem. And similarly, in your regression, the supervised learning, we can have second type of analysis that we call a regression analysis. And in your regression analysis, you can have target variable as a continuous variable. Now we come to the initial part that we have studied with your data type. We had continuous data, we had categorical data. When your target variable in any data set contains categorical information, or we can segregate into different classes, then it becomes a classification problem. However, when we can categorize, we cannot categorize it into a limited set of groups, then it becomes a regression problem, and your regression problems preferably have a continuous data. Such as we can have data set from weather stations. Maybe you want to predict temperature for coming days, or humidity for coming days, or maybe rainfall for coming days. So that will be a kind of continuous data. So you will train your model and it will estimate the future conditions. So that becomes your regression problem, as we can see here, both examples. This is for your classification, and this one is for your regression analysis. Considering the single option, you just have to identify the target variable first of all, and the target will tell you whether it is a classification problem or it is a regression problem with your supervised learning concept. And in both cases, we will have a training data set. We will also have a testing data set, which will help you to evaluate your model. On the other side, when we talk about your unsupervised learning, we will not go much in detail with unsupervised learning or this reinforcement learning, but just for a quick information. In case of unsupervised learning, we have unstructured data. You will not be able to understand what features we have, what target we have directly by looking at your data. It will not be organized properly in your Excel columns and rows. It can be in any format, such as maybe you gather some reviews from a customer's market site, or maybe you get some ratings or reviews from Amazon Marketplace. They will be a kind of unsupervised data sets. You don't know what is contained in that data set directly, but you can just process the patterns out there, and then from there only you can identify different operations that you can conduct on this data. And some popularly used operations with your unsupervised learning include, we can have clustering operation, we can have association operation, we can have a dimensionality reduction and anomaly detection. These are 4 categories that we further have with unsupervised learning. But for this, you first need to understand the unstructured data, which is a separate case study. However, as a beginner, you preferably go ahead with the structured data set where we know the target already and we can train a model based on that target information. Another we have is reinforcement learning, which is basically a penalty and reward based learning. This is basically a combination of both these, inspired from your this supervised learning and unsupervised learning. We get a reinforcement learning environment. And one popular example of this reinforcement learning you can have is with the Mario game that I hope all of you might have played sometime in your life. In Mario game, what we have as a simple structure, we have some penalties, we have some rewards, and your game behave accordingly. Depending upon whether you have gathered reward or penalty, you will see outcomes in your game. So first we have trained that gaming platform, and whenever a person or a character over there performs an action, you might have remembered that we used to hit some blocks over there in that game. So when you hit right block, you get some powers, you get some additional lives, you get some additional outcomes in your rewards, we call them, in your this game. But when you hit the wrong block, either they take up some of your power, they take up your life, or maybe some other penalties you get in your game. So that becomes a best example of reinforcement learning. You don't know about the target, you are not aware about how your data is associated to the target, but you just learn from the patterns. And every time when you perform well, you will get a reward from the model. And when you perform bad, you will get a punishment from the model. And this thing will be fed back to the model itself through a feedback channel. So reinforcement learning is always influenced by a feedback channel that you will get in the form of feedback or reward. And every time your model will learn from this sequence. When it gets punishment, it will learn that, okay, I do not want to perform this thing again. When it gets reward, so it will learn, okay, I'm doing it right and I can repeat this task again. So based on that only, it will understand the data, and then only it will give you the final outcomes based on the conditions. So in several gaming environments, this reinforcement learning is widely utilized. So these are your different elements with machine learning. So just give me a quick update if you got the basic idea of, because we are not discussing it in much in detail. We are just getting the basic structure details about machine learning. So just give me a quick update if you are clear with whatever we have understood, we have discussed here right now. If any part is required to be elaborated, please let me know. I look forward for updates in the chat. I hope everyone is connected because I cannot see anything in the chat by now. Okay, so if no one responds, I'll just consider that you have got the idea whatever we have discussed. I'm not getting in depth with this machine learning because it may otherwise take so much of your time, and we have to mainly focus on several deep learning concepts further in your projects as well. So this was just for introduction that how we deal with data in your this machine learning concepts.
Everyone, please reply on chat and select in the two. You have to select everyone so that ma'am can receive the message or everyone can see the message. I received one response from Tushar ma'am. He is saying no doubt till now.
Okay, sir. So all of you, please post it as everyone so that I can see if everything is going fine. So otherwise, I'll be getting back to your coding platform and we can start with some more discussions on the visualization task. Okay, still no update. So this is really bad, student, that you are not giving me any update in the chat. So I just have to assume everything that yes, it is going fine and we are learning it. So anyway, further, I'm moving ahead with the another topic that we had to discuss today. Thanks for the update. Overview of the important terms. Okay, whatever important terms you have in machine learning that you can even go further. Even I'll share some PPT also in your materials. So that will be a detailed PPT. Whatever I have discussed till now, that will be available in that PPT. So what we have in machine learning, main terminologies are that you have different types of learning techniques. You have supervised learning, you have unsupervised learning, and then you have reinforcement learning also. And along with this, we mainly focus on, considering the limitation of this class here, we mainly focused on your supervised learning that basically is categorized into two portions. We have regression analysis and we have classification analysis. How we decide that which analysis we have to do? Just by looking at the target variable in your data set. So when it is a disease problem, maybe you will have patient information from healthy as well as normal people. So that will be a two-class problem. Either you will have a disease or there is a healthy person. So that becomes a classification problem. In other case, maybe you are trying to predict air pollution. So that will be a continuous data. Like you may have air pollution index values ranging from 0 to 500. So that is a continuous data and you have to estimate it based on those continuous sequences. That becomes your regression analysis. These are the main two categories you will have in machine learning. And whenever you are designing a machine learning model, you always need to pre-process your data and you have to spend majority of time on data pre-processing especially. Because until and unless you do not provide a clean data set to your machine learning model, it cannot behave well. It will just lose some information in between and it will give you poor predictions. So what we prefer, it is good to have a data set with clean details. You need to deal with the missing values. You need to deal with some features. There are unlimited procedures that we apply in data pre-processing, and ultimately the clean data set you apply for the machine learning model. But in case of deep learning, you skip all these data pre-processing methods because there are hundreds of layers inside a deep learning model, and layer after layer, your data set, your raw data set is processed automatically, and deep learning models are able to extract the relevant information automatically out of your raw data. So that is another benefit of your deep learning. However, both of these domains have their own benefits. When you have a limited set of data, a smaller data set, we prefer to go ahead with machine learning. But when there is a huge data set, a very massive data set, we prefer to go ahead with deep learning. So both areas have their own application domains and their own benefits in the area. So I hope this is useful. This information is useful for all of you, and let me know if this is clear now. Okay, great. So now next to this, I'm just updating one more task here. We'll be talking about data visualization. There are so many things that you may need to learn about data visualization because we have unlimited steps inside. We have unlimited methods that can help you to do data visualization. what we have as a core concept in visualization, whenever you get a raw data from the filled environment, we can just see the patterns of that data. We can just try to identify how each variable is distributed across your those data entries. So you can just draw some patterns, you can create some graphs, you can also get some statistical information from those graphs. So several things are possible. We'll just try to include some of the most relevant concepts here for data visualization so that we can just understand how it works. I have shared 2 data sets with you all, and you can use them here for the visualization. One of these data sets I'll be using here for all the executions, and later on you can practice with the second data set also. It will be almost similar kind of data sets they are, so you will not find any major problem with that. So first problem in this platform is how you get that data set on this sheet right now, how you can access your data set. So step by step, we are going to do several things. First of all, we have to load data set. The first task is to load data set. See this very carefully. I'll be executing some operations. There are unlimited methods to load data set on your Colab platform. I'm just using one of them, the simplest one I'm using here. What you have to do is, you might have already downloaded your CSV files. So just open that folder wherever you have those CSV files. Make sure they are not in zip folder, they are outside zip folder, means you have extracted those files. Like for instance, I have them currently on my desktop. So what you can do is, you can go to this files option on your left side of the side menu. Here we have files option. This files option you can open, and there will be a side window on your screen which shows sample data. In this particular window, we can upload your data for the runtime. When we talk about runtime, it means as long as the sheet is active, your data set will be here only. So what we can do is, we can click on this upload button and it will take you to the device folder. For example, I have my data set on the desktop, and maybe I'm using one of these data sets, SCHD data set I'm using here. So this is a medical data set, and we have this with different patient entries over here. So I have obtained this data set right here. Steps are very simple. Just click on the upload button available below these files, and it will take you to the device. Just go to the folder wherever you have your data set. Click on the data set and then hit open button, and your data set will be soon loaded here. Other technique you can follow is, you can simply drag and drop your data set from the folder. You can drag it here, like I have dragged it here. You can drag it and drop it here. That is also possible. Both techniques are possible. Just give me a quick update if you all are able to get your data set on this side window. Then I'll proceed further. If you miss this data set, you will fail to get along with the other procedures ahead. Just simple upload or drag and drop. Okay, thanks for the update. So this is good to know. I hope all of you are following, and I just hope that all of you are doing it side by side, not just listening, because that will not be helpful. You should do it side by side, then only these classes are going to be helpful for all of you. Because then only you can ask your doubts quickly and you can just discuss things over here. So I assume that you have all obtained this data set in the sidebar right now, and now we can start accessing this data set. So in order to load your data set, see, because there are unlimited set of libraries in this Python platform that can be used for data science. We don't have much time to work around all those libraries. But yes, I'll be calling them time and again for different needs here. And what we can start doing is, in order to load your dataset, first of all, we need pandas library, because pandas library help you to access different file formats and you can load them easily on your Python platform. So what I'll do here is import pandas as PD, the very first command specific to your data science. Now, the core Python we have done already. Now we are using data science terminologies here. And in data science, you may need help from different libraries, such as we have pandas library here to load data sets of different formats. It can work through different formats of data set. After getting this pandas library, this is pandas library, I'm just importing it. And as PD, this is just like a nickname I'm giving to this pandas library, and this PD nickname now we can use throughout the program. This is optional. If you don't use the nickname, you have to use the original name throughout the program. And now we have to read your data. So I'm using this data variable right here. And inside this, I'm using a read CSV function, because we have CSV data file. We can see the extension here, .csv. So I'm using read CSV. In case if you have XLS file, you will be using read Excel in that case. So I'm using it for this pattern right now. In order to read your CSV file, you just need path of this data set. And how you get path of this data set? See this carefully. Just go to your data set and you will see 3 dots in front of this data. Click on these 3 dots and then copy path. I'm repeating it again. Go to the data set, see these 3 dots here. Click on these 3 dots and you will see copy path option here. Just click on this copy path and then you can paste that path within inverted commas here. Make sure it is within inverted commas. Single or double quotes, you can use any. This is path of your data file. In future also, if you are trying to access any other file, you can use the same pattern. You just have to copy path of that file and you can put it here. And after this, we can simply check first few lines of this data. It will quickly give you an idea about how the data set is structured. We can see first 5 lines of this data with this head command. I'll write here head of data. That includes first 5 lines or first 5 rows of your data. This brings quick information about your data. In the similar manner, you can even use tail command. So if you try tail command, this will also work in the similar manner. You can apply this in this format, and this will help you to get tail of data, which means last 5 rows. So you can use any of these options. Currently, I'm using head command. You can use other one also to check last few lines. So let me know if all of you are able to draw this data sheet pattern on your screen. I'm sharing this code also in the snippet. You can use it from there. If you are following same procedure to get your data set, the path will be same in your case also. Just give me a quick update if everyone is ready with the data set. Okay, good. Thank you for the update. So now let us proceed ahead. There are unlimited things that you can do with the data, but I'm just going to use few essential operations over here. First, check information about your data. There are some initial details that you can check for your data. And what we can use for that is simple info command. You will see that Python is very simple to learn. Whatever we are trying to do, we have similar pattern for the functions out there. So data.info function I'm using here, and you can see a quick information about your data. And I'll just explain what we get with this. I'm sharing this code in the chat here. A quick update about your data we are getting here. And once you have received this outcome, let us see what we are understanding here from the outcome of this code. First of all, this portion says how many rows you have in your data. So it says 462 rows we have in total. And the indexing, as I told you yesterday, also starts from 0. So 0 to 461 total number of rows we have. Similarly, total number of data columns, we have 10 over here. And then we have detailed information about your data. The index values represented with hash symbol for all your columns. The indexing information we have learned yesterday, so I'm not describing it in detail. So for columns as well as rows, the Python platform will get automatic indexes, start from 0. Then we have the columns. The column names will be updated here automatically. You will get to know what are your column names automatically. Then data type of every column. We can have a mixture of data, we can have float, we can have int, we can have object. Currently in this data set, we have float and int combination. Some features are float, some features are int. And the middle one, this one is very important. It will help you check if your data set have some missing values or not. Non-null count. Null values are your missing values. Non-null values means exact entries available in your data set. So in this data set, if we visualize it directly, we can see total number of entries are 462 and the count is equal in all these columns. It means there are no missing values. In case if we had like 450 here, then we could say that there are 12 missing values in this FAMHIST column. So this will quickly help you know that whether if we have some missing values or not in your data. Let me know if this info function is clear. Is it going fine, students? Okay, good. So this is the quick visualization of your data structure. We are just looking at the structure right now. There are many other things that you can do, but before we move ahead with different informations, let me help you to get few structural informations about your data set. For example, we can check shape of your data. Data.shape we can execute, and it will help you know quickly the number of rows and columns in your data. A quick visualization about the complete data matrix that we have, number of rows and number of columns. This method is widely required while you are working on CSV datasets. Similarly, if you need a statistical summary of your data, that also we can do by using a simple describe function. So this will quickly bring you information about mean, median, mode, standard deviation, and quartiles, etc. of your all variables. This describe function will help you understand structure of your data very precisely. You will find many other operations on the similar grounds just to see different stats about your data. But instead of working in detail on these, we'll mainly work on different visualization techniques for these data points. And with visualization technique, what we talk basically, we have different graphs to plot. And Python supports multiple types of graphs. We can have like 15, 20 different types of graphs that you can use for visualizing your data elements. And depending upon what type of structure you need to see, whether you want to do analysis on single variable, whether on multiple variables, accordingly, you can make selections. So at one time, if maybe you have to analyze a single variable only, we can call it a univariate analysis. And that visualization will require a specific type of plot that we generally prefer, like we have pie charts, or sometimes we can have box plots. There are many other plots in this direction. Univariate means when you have to analyze individual variables. Similarly, the second category we can have is bivariate visualization. In case of bivariate, as the name indicates, we can have two variables when you have to adjust, see the relationship between two variables. Then we talk about bivariate analysis, and it may include different types of plot. For example, we can have a scatter plot for this purpose, although many other options are there. Just one example I'm taking is a scatter plot. Similarly, we can also have a multivariate analysis, like more than two variables will make up your multivariate analysis. And in this case, we can have again different type of plots. For example, heat maps we can have. The list is long. We have unlimited number of plots that we can create, and many of them are also used alternatively, like they may work with univariate analysis as well as with bivariate analysis, depending upon what settings you have applied on those graphs. So considering these, let us start with simple visualizations, and we will also learn why one visualization may be important in comparison to other. So first of all, let us check correlation between variables. We'll just try to understand correlation between different variables. For example, I try to write here a simple correlation function. And if I run it on my data set, you will see this matrix, a simple correlation matrix. And how it works, considering your simple mathematics, correlation is generally in three formats. One is -1, 0, and +1. Three things you may have in your correlation. -1, when you have negative correlation, we call it negative correlation, and it is basically we can call it not in the direction of the actual variable that we have, that we call negative correlation. So like maybe if temperature is increasing, maybe humidity is decreasing, just a random example we are taking. So that will be an opposite condition. One thing is increasing, other is decreasing. That will be an opposite relation between variables. That will be your, with minus sign we can indicate. Similarly, 0 we can see with no correlation, and similarly 1 we can see with positive correlation. When your both variables are varying in the same direction, like when we say that temperature is varying, humidity is also varying in the positive side. So that will be your positive correlation. One is your directional relationship, one is non-directional relationship. Maybe it will be in opposite directions they are working. So these three type of correlation values you have. You can have it anywhere between -1 to 1. When it is close to -1, we call a negative correlation. When it is close to 1, we call it a positive correlation. And you can see these values right here. Appears difficult to understand. You will not be able to understand what these values are representing. As a layman language, this has like a difficult meaning to understand for a beginner. But these things can be simplified if we have a heat map instead of this complicated matrix. That is how requirement of a heat map arises. So let us compare it. If we generate it in the form of a heat map, then how it may appear. And then we will see what these numbers depict basically. So for heat map, I'll be using one more library here, which is a visualization library. There are two libraries that you can use for visualization task. One is Seaborn, and other we have is Matplotlib. Two libraries are widely used for visualization tasks. Many times they can be used alternatively because several functions are common between both of these. However, in general, we prefer Matplotlib for some basic type of visualization elements, and Seaborn for some complicated data visualizations. So first of all, I'm creating a heat map with Seaborn, for example. And I have to first import Seaborn as an SNS over here. And then we can use this SNS nickname further to create your plot. For example, I'm using here one simple sequence, SNS dot heat map. Means from the SNS or the Seaborn library, I'm using a heat map function. This is a function that we have learned in Python. This is an inbuilt function right now. And this function requires some parameter values over here. What parameter values will have? So I'm passing here few values. First of all, the type of data operation that we are trying to display in your heat map. So this is a correlation operation that we're trying to display in your heat map. Second thing, we can also see the outcomes of your these number-based sequences that we can update here. So I say a not is equal to true means I need to see these values in my heat map. If we make it false, these values will be hidden in your heat map. So let us see what we get in the output. This is your heat map. Now you can just have a slight idea about how this is working. See, in your heat map, you can see the matrix clearly. These diagonal elements are 1. So if now you go back to this, you will see 1, 1, 1. And all the diagonal elements will be 1 because they are basically autocorrelation. Means correlation of the variable with the variable itself. Like you can see, class with respect to class shows autocorrelation 1. SBP with respect to SBP shows correlation of autocorrelation of 1. So a correlation with itself becomes autocorrelation and it will always be 1. So that is why the diagonal elements are 1 and we can see them here clearly. Similarly, you will see this bar plot here beside this heat map, which indicates your color information. This color information will help you know that which color is associated to higher rank or lower rank. So for example, close to 0 appear darker. We can see them darker values here. And close to 1 appear whiter. We can see them here in the diagonal elements. So from here, you can easily identify the correlation between different features. You can easily understand that, okay, this adiposity is positively correlated with obesity and the correlation value is 0.72. So in this manner, we can compare it precisely with your each variable. So I'm sharing this particular portion in the snipper also. You all can execute it on your data and just let me know if you understood the part of heat map. Just one type of visualization we have done here. A quick update in the chat box. Okay, good. Okay, see how we use this or not. See, I'm changing this to false. Earlier it was true. Or even if you just remove it, you do not use it, in that case also, this will be your heat map. You will not see the correlation values. Even if I remove this, by default, it will not display you the values of your these correlation. So a not is basically making your annotations visible on your this platform. And for this, you can make this a not true here. This is an additional parameter we are passing into your heat map function so that we can see the values precisely in each block. So you can see them here. And if you find that this is very congested, you may feel that this looks like very congested and we are not able to get a finer plot. So we can also control that. For instance, we can adjust a figure size from here. I'm using a simple code here. with your plot here. I'm using subplots command, and I'll be using fig size is equal to 10 and 10. For example, I'm just trying to increase this figure size. And of course, this will work in combination with Matplotlib, because this figure size we will get from the Matplotlib library. So I'm just getting one more here as PLT. And from this, I'll be adjusting this graph structure. And let us see in the output. We can see the bigger heat map with very clear values now. And we can now compare them precisely well with each feature along. So I'm sharing this one also in the snipper, and you can just see that how figure size possibility helped us to make it more clear for visualization. Let me know if we are clear up to this heat map. Okay, good. Everyone just be responsive in the chat box, then only I'll come to know that you are understanding the concepts. Okay, in the similar manner, we can design some other plots, such as we can have histograms. They are widely used in data science. Histograms, when you have to see whether your data sets are following a normal distribution or not, you can use histograms. And these histograms preferably we use with continuous data type. So let us see how it works on this data. We have a hist function directly applicable on your data, and we will pass some values inside this. For example, I'm using 10 bins. I'll show that how you get to know these parameters also. So currently I'm controlling the figure size also from here. It completely depends on what type of function you are using and what parameters we can pass into that. So figure size I have controlled from here. Then grid I'm making as false. These are different settings I'm applying here. One setting I'll apply later just by showing you the details from here. See, what I have done is, histogram is basically a combination of bins. Something like your bars that we have in a bar chart. So when we have to plot a continuous data, we generally take help from the bins for this. And you can see the distribution here. Depending upon what type of data we have, the distribution will appear here. But currently you can see that these bins are connected to each other. It is possible to apply different settings on this. If you want to maybe make it more precise, we can use a R width parameter additionally here, and I'm just using it with the value 0.9, and you will see the impact in the output. See, we got a small separation between these bins. And we also see that some values here are overlapping. So we can clarify this also. Probably we can increase the figure size. Let us see how it affects. So we can have a cleaner output now. It completely depends how you want to plot your things and how you want to make the appearance. Currently, I have closed the grid. If you want to see it with grid, we can make it true. Unlimited settings you can have with every function. Depending upon what pattern we are following, we can use any of these settings. And now the important thing, how you come to know that which settings you may have to apply. I'm just showing you some tricks also side by side. Maybe after the session, if you want to apply some new things on this data, what you can do. You can just search for the function on your official website for these libraries. How you do that? Just go to your browser and then search for histogram. And we do this using Matplot. So histogram with Matplotlib. And this is your official website, Matplotlib, which is the library in your Python, because Python is an open source platform. So you will find documentation for everything. When you need to know more about the function that we are using, you can just go to the official website, and here you will find everything associated to that function. As I told you while designing function, that a function may have any number of parameters. So here, these functions require you to add some parameters. They are optional. If you don't add, they will use default values. There are functions with default values also. So they are here. If you apply value, there will be updates in your output according to the value that you have given, that we have just seen from here. We applied some values here, and we could see the changes in the output. We can even increase or decrease the bin size. For example, I use here 15 bins, and accordingly, we will see them in the output. See, we have more number of bins now. Depending upon what type of data set we have, these bins will be updated, because in your categorical data, we cannot have more bins. We can have just 2 classes. But when you have continuous data, we can have larger number of bins that show you distribution of all these elements. So this makes the process easier. You can just change the parameters by following these details from the official website. You have complete description over here about every parameter, like how many bins you can add, or how many ranges you can add, how much density you can add. All these things you can make here possible. So when you are learning it on the advanced stage, you can go to these official sites and you can learn through different plots. And you will also see here that we have different types of plots associated to your Matplotlib library, because we are not able to cover all of them. So you find all of them here. So when you have to design any of these, you can just click on that and you will see this is a pie plot, and you have this structure for pie plot, and you can use it in the similar fashion. We can update values based on the pie plot here. So this is how you can use different plots as per your requirement. So I'm sharing this code also in your snippet, and you can use it for the histogram from there. Just give me a quick update if you are clear with the histogram, that how we have used different parameters inside and how it is working. Then I'll create one more plot. Okay, thanks for the update. In the similar manner, we can have, for instance, a density plot. Maybe when you are not happy with this bins type structure and you need some wave-like structure, just in layman language, we can call that. Density plots give you a precise information about distribution of your continuous variables. We generally prefer them for the continuous variable. Currently, I'm applying it on the whole data set. So how we can do that? See, this is very carefully. Data.plot I'm applying here. And with this plot function basically accepts several different types of plot. So we just have to select what type of plot we have to create. So kind is equal to density. I'll show you with other plots also. Currently, we are creating a density plot here. And we can apply a few additional settings, because currently we are using it with multiple variables. So I have here subplots is equal to true, so that it can create some subplots. Then I'm applying layout settings. Depending upon how many variables we have, we can have a different set of rows and columns in your data. These visualizations, basically, you can see we have 10 variables here, and it requires a graph of, we can say 4 rows and 3 columns will be enough. So 4 cross 3 I'm using here as a layout for your subplot. This is some initial setting on your plot. And because we are creating some subplots here, so we can even update subplot settings. This will be easier. See here, subplot underscore adjust function is already available, in which we can apply subplot setting. In the previous case, histogram has all these things within it. But in case of density plot, we are using plot command, and here we can adjust the plot by using subplot adjust command further. So let us see. I'm just using different margins on all directions, left margin, right margin, top margin, bottom margin on your subplot figure. So left margin, I'm entering a random value here. For example, bottom margin, I'm entering 0.1 value, then we have your right margin. For example, I write 2, just some random values I'm updating, and we can see according to that in the output also. Top margin I have updated, and similarly, space between your subplots, the horizontal as well as vertical spaces between your plots we can update. So vertical space and then horizontal space we can have with these values, for example. And ultimately, we can visualize our plot. So let us see what we get. I may have some typos here. Okay, subplot adjust. So this requires basically subplots adjust. There is a typo, and we can see the output right here precisely well structured between all your plots here. Even without these settings, you will get your plots. But if we have these settings, we can have a precise distribution everywhere. We can control these settings. For example, if you want to reduce these spaces, we can maybe reduce it. And we can see the output right here. Now you can see they are closer to each other. So these are your output plots. In case of these histograms, we have bins in the output. In case of density plots, we have these continuous shapes that will just help you understand how your data pattern is distributed among all these values. So we can probably increase or decrease space anywhere in between as per your requirements. We can update these values and we can see the plots clearly in the output. So I'm sharing this one again in the snipper, and you can use the code from there. And just give me a quick update if we are clear up to this point. Then we can stop the session. If you have any queries, just let me know. If we are good to go with this session, whatever we have learned till now, if it is precisely done and you have understood the concept, just update me in the chat box. If we are stuck anywhere, you can let me know, and probably we can discuss that tomorrow also.